Yeah, we are live on YouTube as well as on Zoom. Good afternoon, participants. Welcome to the live session for our course, Fundamentals of Air Pollution, Sources, Effects and Mitigation. Our instructor, Professor Kirpa Ram sir, along with the TAs, Ms. Katina Cheche and Mr. Dr. Varun Shukla, both are here. You can join on Zoom and directly interact with our instructor and the TAs, or else you can watch the event on YouTube and post the queries on the YouTube chat. Over to you, sir.
Okay, so good afternoon, everyone, and welcome to this live streaming session, which is basically on the clarifying your doubts that you have in the lectures, or if you have some questions about the lectures. So, as I understand that if there are questions, we will address that one. You can also ask the question during the live session as well, and we will be happy to share that one.
Sir, we have received few questions through the Google form. Can I share those
Yeah,
questions?
please,
Yeah,
please.
close. Just give me a second. Sir, are you able to view it, sir?
Uh, no, not.
Not yet, sir.
No. So actually, your screen, you are viewing Murli Krishnan's screen, but nothing is there actually. Yeah,
Okay,
now I can see that.
you can see now, sir. Okay, maybe because of the
Yes.
internet issues, sir. Yeah.
Yeah. Okay.
So can I read the first question, sir?
Yeah, please.
Yes, sir. So these are the following questions which we received from the students. We are going to address these questions first. The first question is, how can understanding the evolution of Earth's atmosphere help us design better policies for air pollution control today? Over to you, sir.
Okay. So that's a good question actually. So how can understanding the evolution of Earth atmosphere help design better policies for air pollution control today? So see, there are two actually disjoint questions. This is actually a two disjoint questions. Evolution of Earth atmosphere is happened long back actually, say when the earth formation started, and then say the oxygen evolution, for example, started, and then it get stabilized somewhere around 2 billion years ago, or 2.5 billion ago or so. Now if you remember the problem, when I talk about the air pollution at that point of time, it was mostly, the atmosphere was mostly with the gases. And which were the prominent gases? We were actually having this, and mostly initially the atmosphere was reducing. So basically we had, like, nitrogen, we had CS4, gases like that. We didn't had any greenhouse gases, or we started actually forming CO2 in that one. But then the question arises here, when we talk about the air pollution. So as if you have studied the lectures, we discussed that there are two types of air pollution. One is actually gaseous air pollution, and then other is actually particulate. Now gaseous air pollution, when we say, so if you see that now, once the earth's atmosphere composition was you can consider that was actually stabilized. So oxygen was about, say, 21%, nitrogen 79%, and 1% argon, and then remaining gases. Now the question here is that in this composition the pollutant gases are not included. So this is very clear. It should be very clear that these, in this one, the pollutant gases were not included. Of course they are actually there in the very minor fraction initially when the earth evolution started, or just during the stabilized, the earth's atmosphere got stabilized. Now later on, when during this one, when the life on the earth started, several other gases came into the picture. Industrialization later on, in just few 100 years back or so. But then the question is that at that point of time, we got to know about sulfur dioxide and NO2, and then ozone gases, for example, if you talk about the greenhouse gases. And then we keep on adding many of the questions, many of the other pollutant gases that are there. So this is one thing. So this is what was about the gaseous pollutants. The second air pollution is actually like, particulate matter, right? And then associated with the these things. So we generally call it PM 2.5, PM 10, or sometimes we also now refer PM1 also, right? So this is, and then in this context you other see that whether the benzopyrene is there, lead is there, cadmium is of course not a pollutant, but it's one of the very harmful gases, but lead is already there. So these were the air pollutants, particulate air pollutants, who, if you just imagine that those pollutants were not there at all during the early stage of the Earth's formation. They came just because of the mostly anthropogenic activities or the activities that started later on after the Earth's formation. So yes, in a nutshell, evolution of Earth's atmosphere is another research question or another question, and then designing a better policies to reduce the air pollution is a different one. So these two actually, in principle, they should not be coupled actually, and in principle we cannot couple actually them. Yeah, thank you.
Thank you, sir. Mr. Varun, Ms. Katina, would you like to add anything to this to sir's statement regarding this question? You can share your views also. Otherwise, we can skip to the second question. If you would like to share anything related to this question, you can share.
Yes, sir. Go ahead.
Yeah, okay. Yeah. So we will go to the next question, sir. Is there any specific plant species that can be considered a natural indicator or biomonitor of urban air pollution? That's the second question,
Oh,
sir.
yeah. So I'm very happy to see the questions. They are very standard questions actually, and this clarifies that the students are reading and trying to understand the concept very well. So they are grasping the concept. Yeah, this is very important actually. So I think the purpose of delivering this course is somewhat solved by looking the question itself. Yeah.
Exactly.
Yeah, it's a very interesting question, and there has been lots of to be honest, there has been lots of research on this one, that how uh, understanding the plant species or how they actually behave when there is a high level of air pollution. uh, Unfortunately, so far, this kind of studies are not available actually. Most of the research studies have been conducted either, for example, looking at the specific pollutants. For example, many of the research activities have been done to understand whether the increase in greenhouse gases, especially say ozone, how it is going to affect the crop productivity. Okay, say wheat production or rice production or other kind of production, that kind of studies are there, and this has very clearly established that high level of ozone certainly leads to kind of reduction in the wheat production or kind of productivity. The question, this is a very particular question about the plant species which can be used. So as I said that for this one we need kind of control studies. So by putting the different kind of species in a chamber and then looking their behavior, unfortunately so far what we see in the atmosphere or environment, except I think ozone and some of the gases like carbon dioxide. Carbon dioxide, of course, is used in the photosynthesis, so we should not say that one. But yeah, actually, like some of the things like lichens are there. They have been used to understand the sulfur dioxide pollution in some sense. But that's what I said. That it is when we talk about the Earth's atmosphere and their impact. So the plants are not only going to be affected by one pollutants, right? It will be affected by the all the pollutants that are there. So this means we really don't know that whether that effect is because of the say carbon sulfur dioxide or nitrogen oxide. We really don't know, because it is our ozone, for example. For ozone, it only got confirmed we only got confirmed because there was a separate experiments where different level of ozone concentration were given to the plants, and then their behavior was studied, and then their productivity was studied. So if we really want to do this kind of experiment, we need to choose gaseous pollutants at one place, and then other do similar kind of experiment. But except lichens, I don't think much of the plants have been studied which can be actually used as a biomarker. So biomarkers means we know that okay, this species is dying or this has died, and we can say that it is because of the air pollution. For example, if I just put this in another perspective, let's see that okay, we all know that what you call air pollution has a very adverse effect on human health now, right? This is very clear statement. But so far we really don't know. There are not only one air pollutants that are there in the atmosphere, there are n number of pollutants that are there. And whether the particular kind of disease or particular health effect is caused by which pollutants, such kind of studies are not there even in the human as well. Okay, so such kind of studies in my opinion should be considered in future. And I am happy that if some students are is from say biological or ecological sciences background and has interest in this one, it could be very interesting. Yeah. Thank you.
Thank you, sir, for addressing the query. Let's move on to the third question. How reliable are satellite-based measurements for vertical profiling of pollutants in complex terrains like the Himalayas?
Hmm. Okay, this is again very wonderful question. So now we have to remember two things here. When we do the vertical profiling, we are actually in principle first thing that we measure is like aerosol optical depth. Okay, that what is the total what is the decrease in the light intensity when it enters from the say whatever height to the earth's atmosphere when we reaches on the ground. So you calculate b extension into dx and then you integrate over the height. This is a standard practice that you do the kind of calculation of the aerosol optical depth. Now, so this is first thing that you get. If your extinction is if it is actually a complex terrains like Himalaya, there are two things that are there actually that is very important. Now you have fixed that z is equals to a particular height, say z, but when you are putting on the ground or z is equals to 0, finding that z is equals to 0 is becoming very difficult here because of the complex terrain. So you say that okay, at particular height I'm taking the baseline. For example, if you have a uniform kind of that's why most of the time we report data in the meter above sea level, okay, whatever the height is there, and accordingly we calculate. But in the planar areas that is easier actually, because we don't know that the variation in the ground level or the height which is measured in the meter above sea level, that is not variable. But if you go to the Himalaya, that is actually going to affect. Second thing, that Himalaya, because you have Himalayan ecosystem is slightly different compared to the urban systems or say kind of other system in a way, because in the Himalayas you have not only have plants and other things, you have lots of what do you call snow there actually. So what is there actually, when it is actually snow is there, the albedo will be very high, so the reflectivity is very high. So you have to in principle correct for those things, that how much actually the reflection is there because of the kind of presence of the snow surfaces as well actually. If you are not accounting for that one, then it will be difficult. And then when these are the two things, then once you get the aerosol optical depth data, then what you would do, next thing you have to do, you have to see that profiling actually is profiling will be done on the higher level, say above a kilometer or above few hundred meters. It should not be a big issue, because at that height aerosols are actually more kind of well mixed. The aerosol are actually highly kind of variable in the troposphere, if you consider, or I'm saying, and if you just consider over Himalaya. So in the Himalayan surface, if you just consider say above say 500 or 1000 meters, there the aerosol variability is too much there, and that's where this guy is going to affect. So if you see the vertical profiling, say for example a kilometer above, vertical profiling should not be a big issue, but on the lower level or the ground, near surface, the vertical profiling can have a different can have a biased in the biased, actually can be biased. Yeah.
Thank you, sir. Now let's see the fourth question. How can industries practically balance productivity with real-time air pollution mitigation? Any case studies you recommend?
Yeah, so this is again a very good question, and then yeah, let me put this is in different perspectives. See, when we say productivity of a particular industry, and when we compare a real time air pollution mitigation, now the government has mandatorily done this, that every are, say an industry of having a certain level of energy consumption or certain criteria. There are the different criteria, I am just missing that one. So based on that, each of these actually industries must have their own real time air pollution sensors, or air pollution monitoring stations must be there. Now the problem here is that, you know of course it's a not good to say, but as an educator, as a professor, it is also important to say that most of the time these online measurements are sometimes biased. To be, the data that is actually what is reported is not there. So I mean, they usually underreport the data because they have to satisfy the pollution norms and all those things. Now the one way that, for example, China and other developed countries have done, what they have done, they have of course, so let me see, there is there any case studies. Yeah, there are not much case studies in India, but there are case studies in China, for example. They have so called actually developed a kind of real time monitoring systems, and they have done a particular online mapping, that okay, every time India also has started, for example, in Delhi. So Delhi, they have mapped all the areas and potential areas where the pollution is actually happening very high, or very high level of pollution we have. So they directly pinpoint there, okay, that this point, the this industry at present time said currently 235 is there, and if I know that this particular industry is putting lots of pollutants as per the air quality monitoring stations, there can be a message to the industry that okay, now you either stop or take a proper action to reduce the air pollution. This is one way that actually has been done, but unfortunately such kind of studies are not. For example, I gave that Delhi case study. It's actually done by just measuring the air pollutants, but not done in India, especially for the industries. So such kind of studies are really needed for the industries if we really want to reduce the air pollution. So thank you for the question. This was a very intriguing question as well. Yeah.
Thank you, sir, for addressing that query from the student. Now let's move on to the last and final question posted here. The question is, are there any ongoing intergovernmental projects that integrate aerosol research with real-time policy making?
Oh yeah, this again, this there's lots of governmental projects are there. For example, if just see that IPCC, International Panel on Climate Change. So this not only looks at the climate change aspects, there is a very specific chapter on this one, that how the increase in air pollution are going to affect our ecosystem. There is a very vast study. So I would recommend all the students to go through this IPCC's recommendations, because most of the time this IPCC reports are published. And I mean, it's okay if you can read all the report, that's fine. But if you can't read all the reports, then at least you should read the reports which is concerning with the air pollution, or actually there is a specific topic on the aerosols. So I was fortunate enough to be reviewing some of the IPCC chapters on that one. and I contributed, of course, during my postdoctoral studies. I contributed in a chapter there actually on black carbon. It was basically on the black carbon mitigation and other things. So yes, there are lots of international this IPCC is of course there. There is actually IGAC is there. I'm just missing the name IGAC. Can you see that? What is the name IGAC? What is the full form? IGAC. So IGAC is there. They are actually supporting. Then we have iLeaps. We have. So this is also on the. So I can just put the names. It is ILEAPS. iLeaps. This is a program, very wonderful program. Then we have IGAC. This is also international global international global atmospheric chemistry program is there. So that is already there. Then iLeaps is there. So there are lots of opportunities there, and lots of things are there actually, but they are, to be more honest, they are not looking on the real time policy making. They are mostly research oriented groups. They look for lots of research from all the countries. They do publications and report as well. In India also, I think there is a RRCP is there, AIT is there, Asian Institute of Technology, I think in Thailand. There are things that are actually there, and we recently did work on what you call understanding the air pollution in the Indian and the India and Himalayan regions. So that was also there. I'm just missing the funding agency name there. That was also internationally funded. APN actually, yeah, air pollution network actually. So APN programs are there. Asia Pacific Network program on air pollutions and other things are there. So there are many international programs that are there actually. So if you are really doing good, and if you are interested in doing quality research in this field, this can be one of the very important things for you. Yeah.
So thank you so much, sir, for addressing those queries raised by our students. Maybe we'll wait for some time, sir. If students connects, we will ask
Okay.
them. In the meantime,
Sure.
I'll just check on YouTube whether any questions posted over there, sir. Just
Yeah. Please.
yeah.
So where can we see on the YouTube on the same channel?
Yes, where
Same
we are
program?
streaming now, sir.
Uh-huh.
No, sir, nobody is watching the event, and then no question was posted on the YouTube chat, sir.
Okay.
Yeah, just in case if they post, I will let you know, sir.
Yeah. That will be wonderful. No problem. So I think that's good actually, and
Nice,
I
sir.
think this is also very important initiative that you are putting a lots of live sessions so students can interact, and then at least we even the students are not there, maybe they are somewhere actually, but at least we are able to see some of the questions that were there actually, and I find that these course the questions were very interesting. Of course they are high quality questions, and I'm happy that these questions probably we are mostly from the PG students or PhD students, because the level of questions they had, it's really very good. And yeah, this is interesting that such a course is there, and I would highly recommend to go through these courses, even if you are not understanding if you are a student of science, then you should of course try to learn some of these things, because this is a very fundamental course that is there. And you should learn about air pollution. Maybe we never know. Air pollution management of air pollution is not a single person job. It needs lots of effort from persons, like from say geology, botany, then chemistry, then you need geologists, we need there actually, we need mining engineering students, we need civil engineers who can actually really help that one. If I talk about, like, reducing the air pollutions because of the vehicular air pollution, we need automobile engineering persons there. If we really want to do clean energy and fuel, then we need chemical engineering students in that one. Development of technologies of course are there, so we need technical support are of course are very important, and we need them, because otherwise what is happening, it is if we don't have those things, it becomes very difficult actually. So this is one of the things that we lack. We don't do much of the things in synergetically, we do individually. So individually it is not an effort. For example, I put this air pollution kind of course. This course has lots of aspect that is not covered. For example, biological aspects, then ecological aspects, which of course I could not do, because some of these things were not of my cup of my tea. So not my cup of tea. So these were not covered. But yeah, of course there are other opportunities here. We need people. For example, there is actually aerosols and oceanography is of course there. Air pollution and cryosphere is becoming a very important research topic, and not only this one of the things that is going to be impacting our future generations, not only on that in the terms of air pollution, but also in the terms of water scarcity that is going is likely to be there in few years or so. So we already know that our glaciers are melting, and then if the storage is gone, Antarctica and Arctica, they are also experiencing global warming. So that kind of also things are also there. So we need kind of geologists who can also look at this. Actually, we need geochemists who can look the climate in the past and then decipher that how it is going to affect this one. So yes, we need actually lots of things.
Thank you so much, sir, for sharing your insights on things related to air pollution. Sir, are you able to view the screen, sir?
Yes.
Yeah. So for our course, 623 students have enrolled, and out of those 623, 114 have registered for the examination. And the examination date is on 25th of April, sir.
Okay.
So would you like to discuss about the question paper, like what questions they expect in the final exam paper? Those things you can share, sir.
Yeah, I think the questions that would be there, they are mostly like we already have shared the two kind of after the each session we have given some questions to you, and questions will be related. They may not be actually exactly the same, but then question may be related with that. So the students of course, if the students study the material course material properly, they should be able to do very good in this one. So of course, this is a kind, as the name suggests, fundamentals of air pollution. So the questions are not very advanced level. So the students, I think, will be able to do that one. But yes, of course, the basics and fundamentals should be clear to them, to the students. Yeah, and I wish all the students who are enrolled for the exams all the very best to them, and I am sure they will do very good in that one.
Thank you so much, sir. So our TAs would like to share anything. Mr. Varun, Ms. Katina, would you like to share anything? Otherwise, we may end the session because no students have joined.
Yes, sir. Good
Yes.
afternoon, sir.
Yeah.
Sir, I'm very thankful to getting this opportunity from your side, as well as I'm very thankful to Dr. Kirpa Ram, sir. Uh, he has given me opportunity, both of us. And by using your opportunity, sir, we have already brushed up our knowledge as well as revive our knowledge in atmospheric science and mitigation process. And sir, we want to again connect with you in another program. And sir, I have already answered all queries which will comes from which was comes from the our learners. So I am very thankful to your portal and your team, and also I'm very thankful to our uh, instructor who is every time guiding. Please upload the document. Please upload the assignment. Sumit sir was our assistant. So he is every time working with us at evening or at 12 a.m. night. Every time he is available for our updation and upload the document. So I am very thankful for that much of work, and I'm very interesting interested to join again your course, sir. So thank you, sir.
Thank you, Varun. Ms. Katina, would you like to share anything?
Yes, sir. Am I audible?
Well, you are audible, but your video camera is not that. Maybe you can disable the camera. Yeah.
Okay, sure. Okay. I want to thank for giving me this opportunity. So I thank my sir, Dr. Kirpa Ram, for him accepting this challenge like this. He's reaching out to help the students, and this is such an important course. And now that it is completed, we are very happy. His hard work has paid off, and also, of course, thanks to Varun sir and also to all the other team members like the editors, video editors, and everyone who is involved, and also to you, sir, Murali sir, and to Sumit sir also, to everyone who has made this course successful. I hope the students will be able to learn as much as we have learned from sir's video. In the coming years, it will be very beneficial for all of us. Thank you so much.
Thank you, Ms. Katina. Since there are no more questions, can we end the session now?
I think we can end up the session, and I would like to thank BHU through the SWAYAM for providing this opportunity, and of course the UGC, which of course suggested to go for this one. It was a very wonderful experience for uh, this kind of course, online course. This was my first time, and I think I really enjoyed that one. Sometimes it was a little tough because of the time and other things, prior commitments. But I think we did very well, and we thank all the supporting staffs from your side who helped actually. The TLC Teaching Learning Center at IIT BHU, they were very good actually in doing kind of recording the sessions. Sir, whenever I was available, sir, please upload, come. So they were very ready. And these the two of my TAs, Dr. Varun and Katina, they were really very helpful in assigning all those things actually. Like, sir, we have now uploaded this much things, because after recording the lectures, to be honest, I have not seen much of the things. These are the two TAs who have done their work wonderfully actually. So they were every time going, sir, it is uploaded, edited, and everything is there. Is there any queries? They used to look at it, and so I really appreciate efforts from their efforts, as well as efforts from all the of you actually, and then all the people who were involved in this one. So thank you everyone, and yeah.
Thank you so much, sir, for developing this course, and support was taken care by Mr. Varun and Ms. Katina. So once again, thank you very much for all of your valuable time for doing this session. So we are going to conclude this session. Thank you all. Thank you, sir. Bye.
Thank you so much. Thank you. Bye bye.
Yes.